Hello and welcome to Astronomy Daily. I'm your host, Anna. Get ready to dive into the latest cosmic happenings. Today, we're exploring how astronomers have located the universe's missing matter. We'll also discuss an intriguing theory about the Big Bang originating from a black hole and how artificial solar eclipses are helping scientists study the sun. Plus, we've got updates on the Axiom mission delay, the Project Kuiper launch, and a roundup of upcoming launches from around the globe. So buckle up, it's going to be an exciting journey through space news. Let's get started with a big story. One of the universe's biggest mysteries seems to have been solved. That is, where's all the missing ordinary matter? Astronomers using fast radio bursts, those brief, intense flashes of radio waves from distant galaxies, have managed to map out where about 3/4 of the universe's normal matter has been hiding. And guess what? It's floating in the vast spaces between galaxies, forming like an invisible cosmic web. This is a pretty big deal because it's the first time scientists have actually created a detailed census of where all the universe's ordinary matter is located. These fast radio bursts act kind of like cosmic flashlights. You see, different wavelengths of radio waves travel at slightly different speeds through ionized gas. So by measuring how much each burst slowed down, scientists could calculate the total amount of matter the signal encountered. One cool finding is this cosmic thermostat effect, where supermassive black holes and exploding stars blast gas out of galaxies, preventing them from accumulating too much matter. This research also gives us an independent measurement of the universe's ordinary matter content, which agrees with predictions from the cosmic microwave background and Big Bang nucleosynthesis. All in all, it's a major step forward in understanding the structure and composition of the universe. Okay, next up, we're diving into some mind-bending stuff about the Big Bang. There's a new theory floating around that suggests the Big Bang wasn't actually the beginning of everything, but rather the result of a gravitational collapse inside a massive black hole. Get your head around that one. Now, the standard model of cosmology, which is based on the Big Bang and cosmic inflation, has been pretty successful, but it does leave some questions unanswered. For example, the Big Bang model starts with a singularity, which is basically a point of infinite density where the laws of physics break down. And to explain the universe's large-scale structure, physicists came up with cosmic inflation, which is this idea that the early universe rapidly expanded. And let's not forget dark energy, which is supposed to explain the accelerating expansion we see today. So this new model, it kind of looks inward instead of outward. Instead of starting with an expanding universe, it considers what happens when a really dense collection of matter collapses under gravity. Think about stars collapsing into black holes. The math shows that as we approach a potential singularity, the size of the universe changes, and this collapsing cloud of matter can actually bounce, rebounding outward into a new expanding phase. And get this bounce naturally produces those two phases of accelerated expansion, inflation, and dark energy. One of the cool things about this model is that it makes testable predictions. It predicts a small but non-zero amount of positive spatial curvature, meaning the universe isn't exactly flat but slightly curved. So if future observations confirm this, it could be a hint that our universe really did emerge from a bounce inside a black hole. Spooky, right? And now let's talk about artificial solar eclipses. The European Space Agency, or ESA, has been pulling off some pretty cool stuff with its Proba 3 mission. They've managed to create the first artificial solar eclipses using 2 satellites flying in really precise formation. We're talking about satellites that are flying just 492 feet apart, with their positioning accurate to within a millimeter. That's like the thickness of your fingernail. One satellite blocks the sun, just like the moon does during a natural solar eclipse, while the other one aims its telescope at the corona, which is the sun's outer atmosphere. This is a total game changer for scientists because it lets them study the corona for hours on end. The longest eclipse they've managed so far lasted 5 hours, and they're hoping to get up to 6 hours once they start doing scientific observations in July. What's super cool is that these artificial eclipses give scientists a much better view of the corona without needing any special image processing. They're anticipating producing about 2 solar eclipses per week, which will give them over 1,000 hours of totality during the mission. That's way more than what you get from natural solar eclipses. And because the sun-blocking disk and the telescope are on two different satellites, it gives scientists a better look at the part of the corona that's closest to the sun. All right, next up, a quick update regarding the Axiom Space AX-4 mission to the International Space Station. NASA says the private astronaut mission could launch to the ISS as soon as June 19 as it works to understand an air leak on the Russian segment of the station, though Roscosmos has claimed the leak is fixed. Fingers crossed they finally get going this time. I'll keep you informed. Now, turning our attention back to Earth, or rather low Earth orbit, Amazon's second Project Kuiper launch has been delayed again. Yeah, the launch, which was set to happen from the Florida coast, had to be postponed because of an engineering observation of an elevated purge temperature within the booster engine. So, the Atlas V rocket was supposed to carry 27 satellites into orbit, which would bring Amazon's total constellation size to 54 satellites. The goal of the mission is to provide fast, reliable internet to customers all around the world. So it looks like we'll have to wait a little bit longer to see these satellites join the Kuiper constellation. Okay, next up, let's dive into this massive launch roundup from nasaspaceflight.com. We've got a whole bunch of launches scheduled from all over the globe this week. First up, SpaceX is planning 5 Falcon 9 missions. Yes, 5. That includes a rideshare and the Axiom Mission 4 crewed mission, hopefully, which has, as I reported earlier, been delayed a few times now. There's also the Angara A5 rocket launch from Russia. And get this, the last ever flight of Japan's H-2A rocket is also on the schedule. I know, end of an era, right? Plus, we have a Chinese launch and a Blue Origin crewed suborbital launch to look forward to. In a June 14 statement, NASA said it is working with Axiom Space and SpaceX on reviewing launch opportunities for the AX-4 mission, with the earliest such opportunity on June 19. So, let's break it down a bit. A couple of the Falcon 9 launches are set to take off from Vandenberg Space Force Base in California, while the other 3 are launching from Florida. The New Shepard launch, which is, the one with the crew, is going to be flying from West Texas. And that Angara launch? Well, it's carrying an unknown payload from the Plesetsk Cosmodrome in Russia. Super mysterious. Rocket Lab also announced an Electron launch from New Zealand, and the ULA Kea-02 mission is scheduled as well. It's going to be a busy week. The H-2A that's launching the GOSAT-GW Earth Observation Satellite. It's designed to monitor greenhouse gases like carbon dioxide and methane, and to measure the total amount of Earth's water, too. It's kind of sad to see it go, but the H-3 family is taking over, so onward and upward, right? And that's a wrap for today's space news on Astronomy Daily. Thanks so much for tuning in. I'm Anna, and it's been a blast bringing you all the latest space and astronomy news. If you want to keep up with everything that's happening beyond our world, make sure to visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter and catch up on all the breaking stories with our constantly updating newsfeed. And don't forget to subscribe to the podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. That way, you'll never miss an episode. Clear skies, everyone, and remember to keep looking up. I'm out of here. See you next time.